Flip your notes packet to Unit 2, Angle Properties. So this unit, you can kind of get the overview of what the lesson or what the unit will look like. Okay, the first lesson we're going to talk about is angles or rays and angles. Okay, so a definition of the array is the part of a line with an endpoint, with one endpoint. The endpoint is called the initial point. The initial point always comes first in naming. Okay, so this first one, to name this, you would name it ray CD. First of all, ray, so remember lines have arrows on both sides. Rays just have a dot on one, or you don't really have to make a dot, but an arrow on the right side. Starts here, arrow on the right. Again, just like this shows, C to D, and it's got to be in that order. You cannot say D, C, you've got to say C, D. So this one would be X, W, with again a ray over it. Starts with X, goes towards W. This next one, it says give two names, different names for the same ray. So first of all, that starts at P. They both have the initial point of P. So PC is one of them, and PJ is the other possible name for this ray. PC, PJ. Okay, now we're looking at this picture. It says use the diagram of the intersecting lines. Sorry if you can hear all the plumbing issues we're having at school right now. It's really annoying. It'll honestly kind of like sounds like a whale or something. All right, so example A, it says give another name for ray EF. So here's EF. Another name for that would be EJ. Okay, so EJ. Okay, so EF is the same thing as EJ. They both have the same initial point, and they both go in that same direction. Then it says, are EJ and JE the same ray? And the answer is no, they are not the same ray because they have different starting points and they go in different directions. So no, they have different initial points, and they go in opposite directions and go in different directions. Okay, get that written down. Again, as always, feel free to pause if you need to. This next one, how about EJ and EF? Are they the same ray? EJ, EF. Yes, they are. They both start at E and they go in the same direction. So yes, they are. They have the same initial point and go in the same direction. Okay. Now, the reason I talked about direction is because the direction becomes important here because it says definition of an opposite ray. So an opposite ray it's different rays that have the same initial point but go in opposite directions. So your opposite rays here would be AC. So ray AC and ray AB. So AB is the other one. They go in opposite directions. So ray AB. So they both have the initial point of A, and they go in the opposite direction. One goes in the direction of C, one goes in the direction of B. So they're opposite rays. So it says use the diagram of the intersecting lines to answer the following questions. Are EF and FJ opposite rays? So EF goes this direction. Here's EJ. Okay, and then FJ. They actually go in opposite directions. Yes. However, they don't have the same initial point. So this would be no. They don't have the same initial point. Okay, they don't have the same initial point. All right, so then the next example, JF and JE, are those opposite rays? Yes, they go in opposite direction, right? Here's one, and here's the other. They go in opposite directions, and they start at the same point, J. So you'd say yes. They have same initial point and go in opposite directions. This next one, it says HJ and HG. HJ and HG, they have the same initial point of H. I can even tell by this, they both have the same initial point of H, but they don't go in opposite directions. Okay, so you'd say no, they don't go in opposite directions. They actually go in the same direction, so they would actually be the same ray. All right, last example here. How about how about JH and JF? JH and JF. Okay, they have the same initial point, but they actually don't even go in the opposite direction either. They go in different directions, but not opposite directions. Okay, so you'd say no, they don't go in opposite directions. It's important that they go 180 degrees. Okay, it's gotta, your opposite rays have to form a straight line. Okay, a straight angle. Okay, they have to form a straight angle. All right, definition of an angle. Definition of angle is two rays that have the same initial point. So BA is one ray and BC is another ray, and they both have that same initial point of B. Okay? The interior of an angle is literally when it's on the inside, the exterior is on the outside. So it says the sides of the angles are rays. So the two sides would be BA, that's one side. The other side would be BC. Those are your two sides. That's how you would name the sides. To name the sides, you have to use rays to name them. The vertex is a point, and that's your initial point. So your vertex is B. Remember, to name points, we just use a capital letter. This one, it says name the vertex and the sides. So the vertex here would be F. So we're going to put vertex F. Okay, your sides are FG and FE. The fact that you have to use F first and then go to G, and have to use F first and go to E. You have to start with your vertex when you're naming them. Name the vertex and the sides of the largest angle. Your largest angle is this right angle here. We'll talk more about right angles in a minute, but this largest angle is the whole thing here. So first thing I noticed is your vertex is point Q, and then your sides is going to be QP with the ray over it, and QS again with the ray over it. Okay, so those are your two sides of the largest angle. Okay, now we're going to talk about naming angles. You've probably seen a lot of this before, but the first method is using the three letters that are given, that will usually be given. So, but you have to include the angle symbol, and the vertex has to be in the middle. Okay, those two things have to be true. So you would say angle ABC. Or angle CBA. Those are the two possibilities. But you have to have all three letters, and the vertex has to be in the middle. The other option is to name it using the number that is there. So again, you have to use the symbol, so the angle symbol, and then the number, which would be 5. So this is angle 5. Or if it's the only angle you see, okay, there's not multiple angles, you can just use it using the vertex. So you could say angle G because that's the only angle here. This, you could not say this is angle Q because angle Q could represent multiple different angles there. Okay? All right, so let's practice those 3 methods. It says there are 4 ways to name this angle. So that we could say it's angle 3, right? We can use the number. You could use the angle D. You could just use the 1 letter. You could use the 3 letters, so C, D, E, or angle E, D, C. The vertex has to be in the middle. You got to have the angle symbol in front of all of them. Okay? This one, angle 4 would be one option. Angle F, which is the vertex, would be another option. Angle G, F, E would be another option. Angle E, F, G would be your last option. Again, F has to be in the middle because that is your vertex. All right, so this is when you couldn't, if this was, let's say there was like a letter here, let's say it was like an A here, you couldn't just say that this is angle A. We'll talk about it over here. You couldn't just say this is angle A because it could refer to multiple different things. Okay? Oh my goodness, that noise is getting out of control. So this is angle 1, and we have angle 2. That's all that's given, so those are the only 2 angles we can name. Okay, last example on this page, we have 3 possible angles we could name. We have angle X, P, W, X, P, W, right? We also have angle WPJ. That's this angle here, okay, WPJ. We also have, I could even put that in a different color. Watch this, okay? So the second one we can put in green, and we would have, again, angle WPJ, and we have our last one, which is the big angle, angle XPJ. And again, you cannot just say angle P because angle P could refer to all 3 of those angles we just named. Go ahead and flip your notes packet to angles and their measures. We are actually going to skip this part. Don't cross it out, but we're going to skip the constructions. Okay, so we're actually going to go all the way down to here, and it says define the definition of congruent angles. 2 angles that have the same measure are congruent. Okay, 2 angles that have the same measure. So angle A is congruent to angle B because their measures are the same. Okay, now we're going to classify angles. This is actually nothing new for you guys. You guys have done this before. So we're going to classify angles that have a measure between 0 and 180. So remember that an angle whose measure is between 0 and 90 is an acute angle, and I always think of it as like cute little angle, right? The smallest angle possible is acute. So it's, sorry. So it's something that is less than 90 degrees. So something like this, go the other way, but as long as this is less than 90, okay? A right angle is when it is exactly 90. So this is a 90-degree angle, if I could draw it nicely. Okay, so that's a 90-degree angle, right? 90-degree angle or a right angle, right? Remember we've talked, it's called a right angle. And how you denote that is like a little, almost like a little square in that little corner. And then obtuse angle is when it is between 90 and 180 degrees. So larger than this, but 180 would be straight. So that would be like this. Okay, that would be larger than 90, but not quite 180, because then now a straight angle is 180 degrees. This is a straight angle, 180 degrees straight across. Okay, your kind of turning point, I guess you could say, is like right there. Okay, those are the different types of angles. So then now we have a few examples. Okay, it says name and classify all the angles in the figure below. So the first one, we have multiple angles. We have this small angle, we have this small angle, and then we have the whole thing. So angle 1 is less than 90 degrees, so it's acute. Angle 2 is also less than 90 degrees, so it's also acute. But then we have this whole thing, which we can't call it angle 1 or angle 2. We have to call it angle, we can't even call it angle V, remember, because angle V could be any of these things, so we'd have to call it angle TVR or RVT. So angle TVR is larger than 90 degrees, okay, so then that would be obtuse. Okay. And then we have a few examples here. So I first see I have angle 3. Okay, so angle 3, let's put angle 3, and let's use is. I should probably put is in between all of this. Angle 1 is acute, angle 2 is acute, angle TVR is obtuse. So angle 3 is acute because it's nice and small, less than 90. Angle 4 is that small one right there, which is also acute. We have angle 5, which again is less than 90, so it is acute. Then we have some other ones that combine multiple angles. So like this one right here, this picture actually shouldn't have a P right here. Okay, for some reason our picture does not have P, but it should have P right there so we can name it. So then now let's talk about angle QPS. So I see QPS, and because it has a square right there, that actually tells us that it's a right angle. Okay, QPS. Then we have RPT. So angle RPT, which is obtuse. Okay. And then we have, so we also have QP. So the other one, the only one we haven't talked about is QPT. So QPT is the big one, which is also obtuse. Okay, so those are the different types of angles. I'm not going to go over it in the video, but if you wanted to try, you could try these next two problems. They relate to one another.